to manage the database, we used a database management system, which is MySQL Workbench, and here you can see all the 11 tables that we used in our system. We create those tables with an SQL script. So first of all, we have the media tables, which track all the attributes of every media, so the author's name, surname, publisher, edition, and so on. And then we have a physical state table, which basically track where the media is. So for every set of copies, we have a location. We can have different department as a location, or a different room inside the same building, or different shelves. And for every location, we have a borrowability restriction. That is because not everybody is allowed to borrow media. Maybe for some copies you need to be at least a student, or maybe at least a professor. We have 5 different levels of restriction. And we made a very important assumption about the locations. We don't track every specific copy, but we track a set of copies, group of copy for the same title. So to do that, we use a combination of ID media and allocation, and that was to have a very flexible system able to work even with very old database who maybe didn't track every specific copies, but just the total number of copy for a title. Then we have all the other tables that are needed to run the daily activities of a library. So we have the borrowings table to track the actual borrowing, and we also track the past. So for example, we have the borrowing history to track the past borrowings, and we also track the employee that did the checkout and the employee that did the check-in. We filled the database with 2 SQL script for the media and the physical state. Another thing that I have to mention is that we needed to test some of our function in the program with a huge database, so we wrote this script in Python to create 100,000 random media. So this is the core part of the code. Every line is used to create a random value to set in a field, and then we create a query that is then passed to MySQL. And for example, we used this method to test our custom search function. Alright, now let's have a look on the classes diagram. First of all, I need to explain a very important strategic decision we made. In real life, when you think about objects in a library, they are just books, and they have attributes like title, number of pages, and authors. Well, in our program, the objects are not media, but they are things that resemble the tables in our database. This could sound strange, but actually there are some softwares that do that. They are called object relational mapping systems. We haven't used those tools, but we have integrated our own custom relational mapping system inside our code. In this way, the attributes of a book, for example the title, is not an attribute of our objects in the program. So here you cannot see the attributes title, but those information are just binary data stored inside the computer, organized in a database, and we use the methods of our objects to access and retrieve those information. This is very important because it allowed us to access data only when we really need it, and it was critical to save memory on the server. So here you can see the classes from which we create the objects and the relationship between the objects. There is of course relationship between the media table and the physical state table, because every media can have more locations, and we have then the user and the employees tables, and then we have the interfaces. Well, the interfaces are a bit different from typical objects because they don't have attributes. but they are just a collection of methods. And those red lines are the dependencies, because an interface needs to access the data of different objects and process those data, those informations, and then it affects or traces other tables. So as you can hear, every time I say table or objects, it's the same thing, because in our system they are very close related. And this is because, thanks to our relational mapping system, we shape out of every table an object, and we create a table out of every object. So let's have a look on other interfaces. For example, those interfaces here are needed to add a media or remove media from the library, or to create new locations. And those interfaces, of course, affect some tables. Now a few words about coding. While we code, we thought to use buttons. So, for example, here you can see this variable, make reservation button, which is false. The idea is the user will push a button, and this variable will become true. Then we fill those other three variables with the input from the user, and we get that input in this way with HTML, with form get value. Then, if the button is pressed, we go through the code, we make a lot of checkings. In this example, it's because we have to check if the user is allowed to reserve the media. If that's so, we call a method which is reserve media inside an object, which is in this case is reserve. And here you can see what happens inside the method reserve media. Some of those lines are just the callings of different methods in other objects. Then I'm gonna conclude talking about the searching interface. We wrote our custom search interface for basic two reasons. First of all, we wanted to have a stupid proof and advanced search function. MySQL has already implemented a search, but you have to write exactly what you're looking for. And the idea is the user will remember maybe just a few words inside the title, or approximately just the number of pages of a book, and with our search interface he will be able to retrieve the information he's looking for. The second reason is because a search interface is the fulfillment of an information system, because it has to get input from a user, then it gets data from a database, it makes a lot of checkings, it has to manage and compute a lot of matchings. Every articles and words, as you can see here, have different weights. We even balance every field where we make the search, and then at the end we create a list of information, and we give to the user those information, and the information is still is even tailored accordingly to the kind of user who is using the system at the moment.